I'm going to start off by making a bunch of voters. They're just laid out in 2 dimensions. It's a Gaussian distribution, but random essentially. And we show the median in X and Y with crosshairs. So we're going to prefer the best voting method should elect a candidate that is closest to that median value. And we can create, and each of these voters has a color that ranges from bright orange to bright blue. And bright orange means that they're very savvy in terms of knowing who the front runners are likely to be so that they can vote accordingly, while the blue voters have no clue who the front runners are and simply vote as if each candidate is equally likely to win. You could maybe call this honesty versus sincerity versus strategic. But really, it's just how savvy they are in terms of knowing who is likely to win. And we're going to put some candidates here and just start off putting them randomly. Again, we'd like a method that prefers candidates near the median. Now, you'll notice here, as these shuffle around for a while, what they're doing is it does it a few times so that the savvy voters actually have something to base it on. So it just keeps iterating so that it knows who are the front runners. Now, in this case, all of them picked E as the front runner. But you'll notice that approval and for and against seem to be very similar. Well, this can, first past the post can differ a bit. Let's shift things around a little bit. And what I want to compare now is what if, hypothetically, the voters or the candidates on the left have don't bother having a primary or nomination. They just put them all out there. While the candidate on the right, nominations have eliminated all its competition for those voters. Let's vote again. Now you see first past the post very quickly settles on B as the winner, the one that is isolated, which is not a good choice. And then A and D are the second and third, also not good choices at all. In fact, the ones nearest the middle in this case are the lowest for first past the post, while they're the highest for approval and for and against. Approval and for and against get the first 4 identically, and then they start to deviate down at the bottom. So what this shows is that both approval and for and against do a great job of picking the candidate near the median. Here, F and E they picked differently. They're awful close. So it's not really a problem. Sometimes for and against gets closer to picking the median and ordering them by proximity to the median. Sometimes approval does. And you can alter various variables in terms of how they do the strategy, and it'll change it up a little bit. But here you see I just moved F a little closer. Both of them got it right. First past the post, of course, gets it way wrong. And let's just try a few others just to see what happens here. Let's kind of just bounce them around. F should be the winner. Approval and for and against, again, do very good at determining who is closest to the median. For and against seems to take a little longer. And what that's doing is that's saying it's moving around more later in the process. And that's expected because for and against gives less information, so it has to kind of, the voters need a little bit more strategy until it stabilizes. But they both do, again, a pretty good job. You'll notice they differed on third place between A and B. I'd say approval did slightly better here, but only for third place. For first and second place, they got it right, while first past the post did very poorly. Again, and almost always does poorly. It does not in any way tend to choose the median. It just tends to choose the candidate that is most isolated. Here at first past the post should pick B. It's isolated but also near a lot of voters. That's why it's not going to pick D as first choice. But again, these are both going to pick A. Now my intention is to open source this and allow people to create their own methods, or they can alter how the methods do their calculations in terms of how people vote, the strategy they use, and also they can alter the whole thing really easily. They can alter how the random distribution of voters is, how strategic they are. They can add variables. They can add whatever they want. We're going to open source it and also supply a page where people can do mess around with the code without even having to download anything and run it locally. They can just do it on a website. But let me just show first past the post voting is implemented here in a file. Again, you could just do it in a interactive coding page, but I've got it in a file. And first past the post voting is just created as an object. It's got a name, first past the post, so it can show it in the UI. Has to implement a method called initResults. This simply creates a results object that contains the votes. This is for a particular candidate. This is what's being counted. So the number starts off as 0 and you just add votes because, again, it's first past the post voting. We could add other objects in or properties in here, whatever we want to add. We can do that. But for first past the post, there's not much point adding anything other than votes because that's all we're counting. Then there's the method apply single vote. This is for a particular candidate. You pass in the position. That's an X and Y object that says where they are in that two-dimensional grid. It also passes in an array of candidates. They're sorted based on the last round. So the ones at the top are the ones we think are most likely to get elected. They're the ones who score highest. Then we have num in the running. Now this is going to vary depending on how many rounds we've done and how strategic the voter is. First time it's run, it's going to be equal to the number of candidates, but in subsequent rounds it's going to get smaller, a smaller number, but depending on how strategic they are, it'll stop getting smaller. It won't go all the way down to 2 unless they are purely strategic. The method here simply walks through the candidates that are in the running, calculates the distance from the voter to the candidate, and it's going to vote for the one with the minimum distance. Finally, we have a method which sorts the candidates based on how many votes. So that's basically deciding who is the winner. The one that comes up first is the winner, but it puts them all in order. So this is basically your scoring algorithm. And finally, we just have a method, show candidate, that will print out the votes so that we can see what the results. Approval voting is very similar. We also have an object that just has the votes because that's all we're counting in approval. But we do it a little differently. We first find out the average distance of the front runners. So if it's 3 that are still in the running, we calculate the average of those. Then we walk through all the candidates, not just the ones that are front runners, and vote for the ones that have a distance that's less than the average of the front runners. That's a very reasonable approval strategy. And sort the candidates is the same as first past the post, and show candidate is the same for first past the post. Finally, for and against voting. Here we have plus votes and minus votes because you can add or subtract. Now we could have just done this as a single vote, a single number, but we're going to differentiate. We're going to keep them separate so that we can give better information when showing the results. That's really the only reason to keep them as separate things. Apply single vote. We calculate the distance. This is very similar to first past the post, except we vote for both the most distant and the closest. We vote against the most distant one. That's the minus vote, and we vote for the closest one. And again, this is of the front runners. If you're being strategic, you don't want to waste your votes on ones, whether it be plus or minus votes. You don't want to waste them on ones that are not front runners. And sort, of course, we subtract the minus votes from the plus votes to sort them. And in show candidates, you will notice that we have that extra information to show so that we can show plus votes and minus votes.